Okay, this will go over the Chapter 3 review, and the first two you have to put them into slope-intercept form so you can graph them. So this one becomes y equals, you're going to subtract 3x from both sides, then divide by 4. So you're going to get negative 3/4 x plus 2. Okay, this one here, when you subtract x from both sides and then divide by negative 1, that x is no longer going to be negative, so you're going to end up with x minus 5. Okay, so work through that. I witnessed a lot of mistakes when we did this the first time, subtracting and getting y by itself, but it's really just two steps. Subtract 3x from both sides and then divide by 4. So go from there. You're just going to graph it. This one crosses at 2, y-intercept of 2. It goes down 3 and right 4, or up 3, 1, 2, 3, 1, 2, 3, 4. Something like that. And then this one crosses at negative 5, and it goes up. That has a slope of 1 to 1. So it looks like this solution is right there where it crosses. So the solution ends up being 4, negative 1. That point right there is your solution where it crosses. Number 2, same thing. This one becomes y equals 1/3 x plus 5. Think about it. That x becomes negative, all right, when you subtract it from both sides. So you end up with negative 3y equals negative x minus 15. And then when you divide by negative 3, you have a lot of negatives here, but that crosses out. There's a 1 there. That's positive 1/3, and that's positive 5. All right, when you divide there. So just take your time and do it right. And then this one here, you end up with negative x plus 5. If you subtract x from both sides, y is now by itself. This one crosses at 5. This one has a positive 1/3 slope, so up 1 over 3, or down and left. So that's a positive slope. And then this one crosses at 9. That's 5, 6, 7, 8, 9. Crosses at 9 and it has a slope of negative 1 to 1. So that's decreasing. So right there where it crosses, which is 3, 6, that's our solution. Okay, number 3, solve by substitution. So neither of them are set up y or x equals, so just take your pick. This one's going to be very easy to set equal to x by subtracting y to both sides. Alright, so I just wrote the negative y out front because it's going to be easier to plug in. Remember, substitution is just a plug-in problem. So I'm going to plug in negative y plus 6 for x. X is no longer x. It's an expression, negative y plus 6. So from there, so I'm going to put those two together. I get negative 5y plus 18 equals negative 2. Subtract the 18 from both sides. You're going to get negative 20, so y is going to equal 4. Now it asks for the solution. Well, we know part of it. We know the y. We need to find the x. And that's very easy. All we have to do is plug it back in to one of the original equations. So x plus y equals 6 was an original equation. We know what y equals. So obviously 2 plus 4 is 6, so x equals 2. So that's the first one by substitution. Number 2, now if I look at both of these, the easiest one to solve, it looks like this one. Again, solve this one for x by adding 2y to both sides. So if If I bring this over, it becomes positive. So then I'm going to take this expression right here, and I'm going to plug it in for x. (10y) plus 60 minus 2y equals 4. Put those two together, you get 8y plus 60. Subtract 60 from both sides, you get negative 56. Divide by 8. Y equals negative 7. Now, I still need to find x. So what I would do is possibly put it in right here. You get x minus 2 times negative 7 equals 12. So you get x plus 14 equals 12. If you put those two together, so it looks like x equals, if I subtract 14 from both sides, x equals negative 2. So my solution is negative 2, negative 7. Okay, elimination. This was a method that a lot of you guys enjoyed, I guess. So if I look at this one has a negative y and this one has a positive y. So if I just stack these on top of each other and add right off the bat, there's no multiplication needed because x plus x is 2x, y plus negative y is 0, and 3 plus 7 is 10. So very quickly I can see that x equals 5. If I plug that into one of these equations, I get 5 minus y equals 7. And this one's a little bit harder to think about, but 5 plus 2 makes 7. So how would I make that basically a 2? I need to plug in negative 2 for y, if you think about it. It's probably easier if you plug it back into this one here. It would become 5 plus some number equals 3. 5 plus negative 2 equals 3. So either way, y equals negative 2. So my solution, you can put it in an ordered pair, is 5, negative 2. Number 6. This one takes a little bit more work. So here we go. There aren't any just opposites if I just add right off the bat, and I also have to multiply the top and the bottom to try to get opposites. Because remember, the whole idea of elimination is to get two things that are going to cancel out two numbers. So if I make this positive 20 and this negative 20, then they're going to cancel out. So to make this positive 20, I'm going to multiply that by 4. I'm going to multiply this one by negative 5, and let's see what we get. So I get 20x minus 12y equals 0. Don't forget to multiply everything in there. Then I get negative 20x plus 10y equals, don't forget this one, you get negative 10. So now when I add down, these two are opposites, so my x's cancel out. So I get negative 2y equals negative 10. Divide both sides by negative 2. Oops, you get positive 5. Y equals 5. And then what I would do is plug it back in. So I plugged it into the first equation. You can plug it into either equation. You get 25 minus 3y equals 0. No, I did so. What I do wrong, I plugged it in for x, didn't I? So back up. Plug it in, not for x, for y. There we go. So I started out over here, I plugged it in for x. I needed to slow down. So 5x minus 15 equals 0. And if you think about it, I don't even have to add x 15 to both sides. 15 minus 15 makes 0. So x must be 3 to make that term 15. Think about it. So my answer is 3, 5. Okay, I'm going to try to go quickly here. You're allowed to use your graphing calculator on most of the test. So, if you forgot this, you could always just plug it in your calculator. But when you add, you just add the parts. So it's negative 2, and that's 14. adding, oh, not 14, come on. 9, I'm just adding. I was thinking about multiplication in my head. Okay, so that last one is 9. Number 8. All right, multiplication, if you're doing this by hand, you do, remember you multiply rows by columns. So 3 times 8 is 24 plus 0 times negative 1, which is 0 obviously. 3 times negative 4 is negative 12 plus 0 times 3 is 0. And then 3 times 6, 18 plus 0 times 7 is obviously 0. So that top row is 24, negative 12, 18. The bottom row, so this is the second row, first column right here in this spot. Remember we did this, so if you're used to putting templates there, so 6 times 8 is 48 plus 2 is 50. No, 48 plus 1 is 49. All right, 6 times 8 is 48, plus negative 1 times negative 1 is positive 1. All right, 6 times negative 4 is negative 24, plus negative 3, or minus 3. And then 6 times 6 is 36, minus 7. So 6 times 6, negative 1 times 7 is the negative 7. So I get 49, that's negative 27, and that is 29. That's how you do it by hand. If you want to use your graphing calculator, remember there's the second matrix. You get into this screen right here, and you edit, change this to a 2 by 3, and you can plug in what you need to plug in and multiply matrix A times matrix B. Actually, in this case, matrix A is a 2 by 2. So you just plug in 3, 0, 6, negative 1, etc. So I'm going to kind of leave it up to you to remember how to use a graphing calculator to do this problem. All right. Number 9, determinant was very easy by hand of a 2 by 2. You do the diagonals, so 0 times 5 minus 3 times negative 6, so that's 0 plus 18, which is 18. So recall that quick. Inverse is 1 over the determinant times the matrix. These two positions are switched. Okay, so if I have the matrix A, B, C, D, all right, and I want to take the inverse of that, okay, if I want to take the inverse of that, I do 1 over the determinant of the matrix, switch D and A, and then switch the signs of B and C. Now, you notice that these two matrices are the same, so the determinant is 18, and so we don't really need to recalculate that. But what we do need to do is switch the 5 and the 0, and then switch the sign of the 6 and the negative 3. Now on the exam, be ready to multiply this to every single one of these and see which one's equivalent. Alright, so you can multiply everything in there by 1/18 to get the decimal form. Okay, the determinant of a 3 by 3 by hand. I'm going to grab a smaller marker here. Find it, there we go. Alright, so 0, 2, 4. You rewrite the first two columns, and then you draw. A lot of people use a highlighter here, but you multiply the diagonals, and 8 times 9 times 4 is 288, and negative 5 times negative 6, that's 30, times 2 is 60, and then these diagonals All right, so that's 0 because there's a 0 in the strand. There's another 0, and then 7 times 2 is 14. 14 times 8 is 112. So I get those two totals. Obviously that's 112. This one is 348. So then I take the lower diagonals, so 348 minus 112, and get 236. Okay, in your calculator, if you plug in this matrix in A and you just find determinant A and press enter, it will give you the right answer. Alright, last one here. Remember we found the area of a triangle. Oops, don't need the... And we wrote all the points in this column, and then we filled in ones here, and then we just find the determinant of that matrix. So the determinant of that matrix will give you the area of the triangle. And I'm not going to show that but if you did this correctly, you should get the determinant of negative 55. Obviously, we cannot have a negative area, so the area, we just turn that positive. So 55 square units is our answer there. So you find the determinant of this just like you did number 11.